Let's look at why is it that x to the power of 0 is equal to 1, or for that matter, any number to the power of 0. Say for instance 3 to the power of 0 is equal to 1. We're going to prove this two ways. Our first way is going to use rules of logs and powers, and the second way we're going to use patterns. So let's begin with a basic example. Imagine we had the scenario 3 to the power of 4 divided by 3 to the power of 4. Now we know 3 to the power of 4 is 81. So this is 81 divided by 81, and 81 goes into 81 one time. So that's a basic example. Let's push our knowledge a little bit. Imagine we had the scenario any number to the power of 4. Let's call it x divided by x to the power of 4. Again, it's the same number divided by itself. So anything divided by itself must give me 1. Nothing groundbreakingly new there, hopefully. So let's look at our rules of indices and logs, which tells us that x to the power of anything, so x to the power of p I'm calling it, divided by x to the power of some other power, let's call it q, is the same as taking it as x to the power of p minus q. So let's look at our first example here again. Our first example was 3 to the power of 4 divided by 3 to the power of 4. If we use our rules of logs now, that's going to be the same as 3 to the power of 4 subtract 4. And 3 to the power of 4 subtract 4, 4 subtract 4 is 0, so that's equal to 3 to the power of 0. Let's look at our second example again for a second, our x to the power of 4 divided by x to the power of 4. Using our rules of logs, that's the same as x to the power of 4 subtract 4. Once again, 4 subtract 4 is 0, so that's x to the power of 0. So now we're in new territory. Look what we've just got. We have 3 to the power of 4 divided by 3 to the power of 4 is 1, but we also have 3 to the power of 4 divided by 3 to the power of 4 as 3 to the power of 0. So let's make that conclusion. So we now know that 3 to the power of 0 is equal to 1. We also have it that x to the power of 4 divided by x to the power of 4 is the same as x to the power of 0. So let's make a further conclusion. Therefore, x to the power of 0, or any number to the power of 0, is also equal to 1. So that's why x to the power of 0 is equal to 1. Let's come over and have a look at it through the use of patterns. So again, let's stick with our 3 to the power of 4 here for a second. 3 to the power of 4 is equal to 81. If I was to divide that now by 3 into 81 gives me 27, which is the same as 3 to the power of 3. Let's keep going. Dividing by 3 once again. 3 into 27 is giving me 9, which is the same as 3 squared. Divide again by 3, let's see what happens. I'm leaving myself with 3 into 9, which is 3, which is 3 to the power of 1. And let's go again. This is the important one now. Divide by 3. 3 divided by 3 is 1. And look at my powers here every time. Look what's happening. It's going from 4 to 3 to 2 to 1. So the pattern must tell me that this one is 3 to the power of 0. So once again, we've shown that 3 to the power of 0 is equal to 1. Now this would be the same as x to the power of 0 would equal to 1. It's the same as any number to the power.